Okay, so very basic stuff here. We're going to talk about, and what I mean by basic, I mean like the introductory to simplifying radicals, and we're going to take that a little bit farther and what we can do when we multiply radicals and what their properties are and such and so forth. So one of the things we definitely have to put out here are radicals and powers are inverses of each other. So what you need to understand is that here is my radical symbol, okay? The root is based off of what indice that I have. So this part here is called the indice. So first off, the square root is never written with a 2. So anytime I want it to be above a square root, I would say I would write a 3. This one here, if I wanted to undo it, then I'd have to have something to the third power. So something raised to the third power undoes a radical of the index of 3. Just so that you're aware of that. For this video, we're just going to start off with the very basic introductory to this, which is going to deal with square roots. So what we need to know is that the square root of x and x squared, so if looking at the actual x, so again the x here, that the square root and the power of 2 are the inverse operations of each other. So if I want to get rid of the square roots off of this x, what I actually have to do is square the whole thing, and what then I'm left with is that and that basically undo each other, and I'm left with the basic expression underneath there, which is just an x. Again, if I want to get rid of a square, I would take the square root, and the square root of the whole thing is just going to give me what was the basic expression under there, which is x. So these two things are inverses of each other. So I hope you understood what I was just going through there, because that's the fundamental thing that you're going to need to have to go through today, or through my lesson today. All right, so basically starting off here is let's talk about what it means to simplify a radical in the first place. So all a square root does is it tries to find a perfect square and undo it. So your list of perfect squares that really we're concerned with is 1, not so much. We kind of ignore that one because it's kind of like the anomaly where if I take the square root of 1, it just gives me a 1. So it's important to know that, but we're not going to be able to use it for the purpose of this video. So we're really interested about 4, 9, 16, 25, 36, and so on. So these are all your square numbers. So again, if I square 2, I get 4. If I square 3, I get 9. If I square 4, I get 16. If I square 5, I get 25. If I square 6, I get 36. These are the ones that we're worried about. These are the ones we're trying to find somehow, some way. So, square roots. So let's say I come up with the square root of 32, and my directions are to simplify this. Now, because a square root is the inverse of a power, and powers are the basic thing that means you take a base and how many times you're going to multiply it by itself. And the final answer is going to be a product, because a product gives you either it's two things multiplying together, and if I look at them as a whole, they're called a product. If I look at them individually, they're called factors. So 32, because I put it under a root, is automatically, this number has to be a product of something. Okay? So since this number has to be a product, there's some things mathematically that we can do. And one of the things that you can always do is you can take a product, okay, and you can write it out as its factors. Okay? So when you factor something, you're basically trying to write it out as into a strand of multiplication. So I can now rewrite 32 as a strand of multiplication. So I can do a couple of things here, and what I'm going to do is just look for pairs, because I'm going to look for the highest number. So in this case, we're going to learn to do simplifying radicals by using factor pairs. So if I take a look at 32 and I go, okay, let's write out all the things that multiply to make 32. Well, 1 and 32. Again, I said we don't really want to use 1, but I'm going to write out just because. 2 and 16, and in this case, I'm actually going to stop. Yes, 4 and 8 will work as well, but I'm going to stop because I found one in my list. So the minute I find a factor pair that's in my list up here, so 16 is in my list, this is what I'm going to break 32 into. So the product I'm going to write as factors. So the square root of 32 is now 16 times 2. And it's irrelevant how you write it, but what I now want to show you here is that this can now be broken apart into the square root of 16 times the square root of 2. Okay? So that's an important thing here because now the square root of 16. All right, so if a square root, when I type this into my calculator, it gives me 4. Basically what I'm asking you is now, what number, square root, what number am I squaring to get 16? So the number that I'm squaring is called the root. So up here when I take a look at this, okay, 4 is the number I square. 4 is the root that I square. So the square of the root. So the root being squared is 4. So this 4 becomes this, so the square root of 16 becomes 4, and then I just multiply it by root 2. So this 2, by the way, I can't, in this case, do anything more with. I can't write this as factors and find it in my list up here. So the final answer to this is 4 times root 2. So just to go through that again with another problem. So we're going to use 72, okay? So 72, say I want to simplify this. Again, this is now a product because it's underneath a radical, and anything under a radical automatically is a product. So therefore, I now can factor this. So 72, okay, again, 1 and 72. 1's the anomaly that we're not going to use. It is a square number, but it's not going to help us in our list. So I want to go to 2, so 2 times 36. I'm stopping now because I found one that's in my list. Now this list continues, and you should know these numbers all the way out to pretty much the root of 20 being squared. So this one here, 36, there it is. It's in my list. So the root that got squared is the 6, is the number being squared, so the root is 6, okay? So the square root now of 36 times 2, so I'm writing it out. So I can break this apart now as to 36 times root 2. So the square root of 36, again, what is the number I'm squaring to get 36? And up here, 6 is that root, so this is 6, so root 2. Now, it's 6 times root 2. We don't have to write the multiplication here. If we just write them next to each other, they're the same thing. So let's do this again with just one more. Okay, so if I have the square root of, say, 147, so 147 doesn't look nice, but we know it's a product, so therefore we have to go through and factor it. So I write 147, and I always start off with 1. I follow the same process every single time. I go 1 and 147. Can I do 2? 2 and a number won't give me, I need whole numbers here, so I don't want decimals and I don't want fractions. So 2 times something, no, won't work. In this case, 3 times 49 will work. Now I'm gonna stop because I know 49 is my number, because if I went up here and did 7 squared, it would give me 49. Now it wasn't in the list that I had up here, but what you need to know is these numbers, like I said, something pretty much up to a root of 20 being squared. So right now I have 3 and 49, so it's in my list. So I just come up here, I go the square root of 49 times 3. Okay, so then I can break this into root of 49 times the square root of 3. What is the number being, what is the root of 49? So again, what is the number being squared that makes 49? And that answer is 7, okay? So this is now 7 root 3, okay? So, and if you want to think about why is that the square root of 49 is 7, and again, remember it has to do with inverses. So 7 can be rewritten as 7 squared. And remember how I talked about earlier? Square roots undo squares, boom, boom, and I'm just left with the number 7, okay? So that's what they are. So if you want to see something more mathematically behind it, there it is, and it's a 7. Okay, so I know I've taken quite some time at this point, so I'm going to skip right to multiplication right now. Multiplication isn't that bad, so I'm just going to do 2 problems with multiplication. So let's say I take the square root of 7 times the square root of 14. Okay, so what I'm going to now look for is, okay, that I know that this is a product and I know that this is a product, yes? All right, so if I know that they're both products, what I'm really going to be looking for is common factors of these products, okay? Because if I have these common factors, that's going to help me do this a little bit quicker. So what I want to notice here is I could take, for this, I could take if I have a square root, okay? If I take the square root of something, I am allowed to multiply the 7 by the 14. If they're both under the same root, okay, a square root, and I'll discuss this more a little bit later with you guys, but what you need to know for now is that anything under the root can be multiplied together and you're okay. So if you want to think about this and you want to do it one way, so one route is to do 7 times 14. And 7 times 14 just so happens to be 108, or 98, sorry. So 98. So 7 times 14 is 98. So I can write this as the square root of 98, okay? So now I have to go and say to myself, okay, what are the factors of 98? Well, the factors of 98 are 1 and 98, okay? 2 and 49. Aha, I'm gonna stop. So there's my 49. So now I'm gonna break this into the square root of 49 times the square root of 2. Okay, I could have written it all under 1, but I'm just kind of skipping that step from the previous. And what I have now is 7 root 2. All right, so again, I can just multiply them, get my new number, and then try to take the factors of that number to find a square number. And that's all I'm doing, because again, a root is trying to dive through a problem and get rid of it, okay? So, on to the next one, okay? So I'm gonna show you how you could have done this a little bit differently, and this is the only problem I'm gonna do. So the way I could have done this a little bit differently is I could have said, okay, factors of 7 are 1 and 7, so I'm just left with a 7. But is there factors of 14 that are common with a factor from here? So now I'm looking for in their actual factors, so 1 and 14, okay, 2 and 7. Do I have common numbers in here? So when I do this, I can rewrite this now as the square root of 7 times 2. Yes? Okay? So instead of actually now doing the multiplication out, I can write this as one long strand under one root. So before I actually did the multiplication, and this time I'm just going to write it out as one long common strand, which is 7 times 7 times 2, right? Well, in this case, 7 times 7 is 7 squared. So the square root of 7 squared times 2, this gets undone, and I'm left with 7 root 2, okay? So what you'll start to realize is that after a while, you can skip from here to here once you get the hang of it. I wouldn't do that as of now, but what you should begin to see here is that I'm doing every little itty bitty step, but this is sometimes easier, especially if these numbers are really large, because then if you have two large numbers, multiply them out, you're gonna make a larger number, and that's not necessarily gonna be easier. So for this is just how I went about this way, and this is breaking it into factors and looking for common factor pairs. Now I'm choosing common factors, okay? And let me show you what I mean by that again, all right? So I have another one I'll do here is square root of 6 times the square root of 18. So for the purpose of this video, I don't want it to be too crazy long here, but square root of 6. Now, I know I have 6 here, so what I'm really asking myself is, can I write 18 as a factor of 6? And the answer to that is, I hope we would all know that I have 1 and 18, 2 and 9, or I have 3 and 6. So in fact, 18 can be written as a factor of this number over here. It won't always work out that way, but like I said, I'm starting with very basic ones here. So this now can be rewritten as the square root of 6 times the square root of 6 times the square root of 3, right? Okay, so square root of 6 times square root of 6, if I multiply them together, I get the square root of 36 times root 3, okay? So in this case, 36 happens to be 6, which in this case, I now get 6 root 3. Okay, so I did this a kind of little bit differently. I took these out and I broke it into the two of them right away. And I'm now left with square root of 6 times square root of 6. I then multiplied those just to show you, as opposed to writing as 6 squared, I wrote this now as the square number, which is 36. And the root of 36 is, again, what number squared gives me 36, which is 6, which is the root. So therefore I get 6 root 3. So I hope that helps with today with what you're going to be working through.